Alright, we're going to work with the circle in this section. Quite simply, we define a circle to be a set of points that are a fixed distance, r, which we call the radius, from a fixed center point. And we're going to denote the center of the circle with coordinates h and k. The standard form for the equation of a circle that has center hk and radius r looks like this. It's the standard form because if I see an equation in that form, I can pick out immediately where it is and how big it is. I can tell where the center is and how big the radius is. It's pretty easy to see why that's the standard form or where that comes from. So I'm going to start. Here's the circle. Here's the geometric definition. There's my fixed point in the center. There's my radius r. And P here is just a point. It could be any point on the circle. We've just drawn it up there. And what I'm going to do is one of our favorite things to do in the plane is to draw some perpendiculars. So I'm drawing this horizontal line over from the center, this vertical line down from the point P, and when we do that we have a nice right angle there, so this is a right triangle. The coordinates of this point, it's got to have the same x coordinate as the point above, so that x coordinate is x. It's got to have the same y coordinate as the point to the left, so it's got the y coordinate k. And now we're going to find these lengths of the legs. So this vertical length, the vertical length is always top y minus bottom y. That's y minus k. A horizontal length is always right x minus left x, so that's x minus h. And Pythagoras says that x minus h squared plus y minus k squared is equal to r squared. And that is what we have here in the definition above. So as I mentioned before, we call it the standard form because if I have something written, if I have a circle written in standard form, I immediately know where it is and how big it is. So we want to find the center and radius of this circle. This will take almost no work at all. You just have to keep in mind, I'm going to scroll back up here for a moment, the coordinates of the center are h and k, and we are subtracting h and subtracting k here. So we're going to have to kind of switch signs when we interpret the equation. So take a second and see if you can come up with what you think is the center and the radius. So the center is the point 1, negative 2, so I've had to flip these signs. And the radius is the square root of 16, or 4. Remember that the number by itself in the standard form is r squared, so we have to take the square root to get the radius. Next, this says find the equation of a circle with center 2, 1, which passes through the point 4, 8. So, we're seeing a couple of different flavors of questions that we can be asked, and this is the two varieties that we'll just encounter over and over. And one is they give us an equation and they ask us to find some geometric information, like we did in example 111. Or they can give us some geometric information and ask us to find the equation, and that's what we're doing here in 112. So it's an equation of a circle, so I know I'm going to start with something that looks like this: x minus h squared plus y minus k squared equals r squared. I know the center, right? So I can already plug that in. X minus 2 squared plus y minus 1 squared equals r squared. So the only thing I don't know is the radius, or the value of r squared. But I do know that it passes through the point 4, 8. So here's a big kind of takeaway. This is going to be a recurring theme. And we always want to remember that if I know the coordinates of a point that a curve passes through, I can plug in those values for x and y in the equation itself. So the circle passes through the point 48. And so what I'm going to do is substitute x equals 4, y equals 8 in the equation. So when I do that, now the equation looks like 4 minus 2 squared plus 8 minus 1 squared equals r squared. And look, now this is enough for me to figure out what r squared is. 4 minus 2 is 2, 2 squared is 4, 8 minus 1 is 7, squared is 49. So we get 53 is equal to r squared. I don't need to find, they didn't ask me to find the radius, so I'm not going to take the square root, but I know that this is what I'm going to plug in up here. So now the equation of my circle is x minus 2 squared plus y minus 1 squared equals 53. And that's what they asked us to find. Okay. So, hopefully at this point we're all kind of gaining an appreciation for the standard form of a circle. It's easy to kind of pluck information about our circle if we have it in standard form, but not all circles will be given to us in standard form. In fact, I know if I'm looking at the equation of a circle, the general form for a circle, now remember back when we were talking about the straight line, I said the general form is basically going to be when everything, you have all your terms on one side and it's set equal to 0. So I'm going to scroll back up here for a moment. I'm going to look at this circle in example 111. Now what if I took this and I just expanded out these products? So x minus 1 squared is x squared minus 2x plus 1. Y plus 2 squared is y squared plus 4y plus 4, and that's equal to 16. And then I kind of gather all my terms on one side. So I have x squared plus y squared minus 2x plus 4y. And let's say I've got a plus 5 on this side, and if I subtract 16, that would be minus 11 equals 0. So here's the thing. This equation here is the same as that equation, right? They describe the same circle. We can see immediately why this form is preferred, why we call this standard form, right? I can take that equation, I can look at that equation and get this information about the center and the radius that is harder to get out of that form. So but that equation in the bottom right there, the one that's all expanded out, is still the equation of a circle. So if I'm starting with an equation like that, I want a way to get it into the standard form, right? Because that's what we prefer. And we have a way to do that. We call it completing the square. And I'll just say right off before we start this, I know if I'm looking at an equation of a circle that's all expanded out, so it's not in standard form, I can still tell it's a circle because it'll have both an x squared and a y squared, and the coefficients on x squared and the y squared will be equal. They'll be the same coefficient. So here's basically how we complete the square. You're going to get the constant by itself. You're going to group the x's with the x squared and the y's with the y squared. And then this is the part right here. We're in step 3, add the appropriate constants. That's sort of the magic step that completes the squares. And so I'm just going to kind of show you that process by example. So what I'm going to do first is the organizing. I'm going to get the 24, I'm going to add 24 to both sides. On the left side, I'm going to group the x's with the x squared. So x squared minus 6x, I'm going to leave some room for the magic. Plus y squared plus 8y, leave some more room for some more magic, equals 24. You always want the coefficients of x squared and y squared to be 1. Here they already are 1, and so we're all set there. If they're not already 1, we would go through step 2 where it says, if necessary, divide both sides by the coefficient of x squared and y squared. So now that I've already done the organizing, I'm going to complete the square, and we're going to do it twice, one for the x's and one for the y's. I'm going to take a look at this coefficient on x. That is -6. I'm going to cut that in half, and I'm going to square it. So -3 squared. I've added the square of -3 to this side. I've got to do the same thing to this side. And now I'm going to do the same thing for the y's. The coefficient on y is +8. So I'm going to add half of 8 and then square it. So 4 squared. Add that to both sides. Now, because we were so clever about what we added to both sides, this group of 3 terms here, x squared minus 6x plus -3 squared, that's a perfect square. Now you could go through and unfoil it, factor it yourself and see what you get, but you'll find that you get 2 of the same factor. You're going to get x minus 3 times x minus 3. So this is just x minus 3 squared. And that's always how this works out. You grab the x, you grab the -3, and there's your perfect square. We've got another perfect square here with the y's. That's what a perfect square looks like. I grab the y, I grab the +4. So I've got x minus 3 squared plus y plus 4 squared. On the other side I got some arithmetic to do. 24 plus 9 plus 16 is 49. So that's part of what they asked us to do, complete the square, to write it in standard form. So there's standard form. And now we're going to glean some information about it. Take a minute and see if you can't come up with the center and the radius before I start writing it down. So the center is going to be the point 3, -4. The radius is the square root of 49, or 7. Alright, let's do one more. We're going to complete the square on this circle. Now again, I can tell it's a circle because I have both an x squared and a y squared, and the coefficients are both the same. Now they're not both 1 this time. They're both the same though. The constant is already over by itself on the other side of the equation, so I'm going to start out this problem. I've got to get a coefficient of 1 on x squared and y squared, so I'm going to divide through by 4. And then I've got x squared plus y squared minus 16, minus 4y. I'm going to leave some space for the magic. This is equal to 9/4. Now you'll notice there's no x term. There's just an x squared term, but no x term, and that means that the x's are already a perfect square, right? If you want, you could think of x squared as x minus 0 squared. So we need only complete the square on y. The coefficient on y is -4, so cut that in half and then square it, so plus -2 squared. Plus -2 squared. I've got x squared plus these terms here, these 3 terms, they form a perfect square, and it's the square of y minus 2. And then on this side I need to do some arithmetic, so I've got 9/4 plus 4 over 1, get a common denominator of 4. 16 plus 9 is 25. 25/4 on that side. So there's the standard form. Next we're going to find the radius and the center. The center is the point 0, -2. And, oh, sorry, that's a mistake. 0, +2, because I have to switch the signs. And the radius is the square root of 25 over 4. Now, we're allowed to split up radicals over division, so that's square root of 25 is 5, square root of 4 is 2, so the radius is 5/2.